Has this ever happened to you where you're doing your laundry and you get everything in there and then you realize you don't have a Tide Pod? And so now you gotta go take everything out and you missed today's load of laundry. Or how about this? Same thing as at first, you forget you have a Tide Pod, and so now you gotta walk all the way back to your bathroom where you keep them. And then you're waiting, come back, and now you finally have one to actually do your laundry. Don't you wish all this hassle could be avoided? Introducing the Lazy Laundry, the world's first automatic Tide Pod dispenser. You begin by loading up to 7 Tide Pods into the specially designed storage chamber which is fixed to the top of the washing machine. Then you put on the lid so they don't just all fall out again. Then you just turn on the machine and you're good to go. How does this work? I hear you cry. Well, it's pretty simple. A linear actuator, like the one that's shown on screen, pushes them into a custom-made chamber which they have previously fallen into. Here's what the linear actuator looks like mounted into the custom-made chamber. The white wire is a pressure sensor wire. It basically goes from the pressure sensor in the washing machine and brings power to everything else. And so if the pressure sensor reads that it's in the spin cycle from the water in the machine, then it will activate. However, if it realizes that it's in the drain cycle, it will deactivate and allow a second Tide Pod to fall into the chamber and be spit out. As for the light gray wire, that's a debugging wire connected from the Arduino to the computer and is unnecessary. The red microchip looking thing is a motor controller. It's meant to control the direction of the linear actuator, and so it tells it to go forwards or backwards. The big metal box is an AC to DC converter, converting the 120 volts from the washing machine to a more reasonable 12 volts to the whole circuit, which the linear actuator can handle. And then there is also a step-down converter in there, which converts the 12 volts into a safe 5 volts for the Arduino to handle. Here is an example of the machine working at its finest. The first and most obvious flavor of engineering that this uses is electrical engineering, through the circuitry that we made and also the conversion from 120 volts AC power to the measly 5 volts of DC power. The second is through mechanical engineering, and the overall design process was mostly focused on that, with the chamber and the storage sections both being very mechanical in nature and meant to be as simple as possible with as little moving parts as is necessary.